Okay, chapter 10. So far in our class, we've been trying to ask questions regarding only one population. Okay? So, for example, right, our null hypothesis could be, right, what is the average income? Is the average income in San Francisco greater than, let's say greater than 95,000? Right? We can ask that question, or we say things like, well, what is the proportion of people who are high income earners, right? Is it 75%? Is it less than 75%? Right. So these questions are questions regarding the parameters of one single population. Okay. Now in this chapter, we'll talk about two population. Right, so imagine you have two populations. Maybe we're looking at we want to compare between LA and New York, right? And each of these populations has a mu1, and has a sigma, right? Mu2, sigma2, right? And we might try to say, well, does you know does LA have higher income than New York, right? So by asking that question, what we're essentially saying is mu1 greater than, right, greater than or equal to mu2. Okay. So now we're going to take the same concept as in our hypothesis test and apply it to make inferences about two population or parameters in two population instead of just one. Now, in our previous hypothesis test, the foundation we build upon is always the sampling distribution, right? So first we create an estimator, right? We're trying to, we're trying to ask some questions about mu. Therefore, we create an estimator called x bar. Okay, so we say that, well, x bar is an unbiased estimator. For mu. Okay, and we get the sampling distribution of x bar, right? This is the key. What's the sampling distribution of x bar? Okay, and we know that, well, if sample size gets big enough, right, n is greater than 30, or if the original population is normal, right, we can draw the normal distribution. So okay, so we can do that, and then because x bar is unbiased, we know that it centers at mu, and then furthermore, right, okay, so make sure you label your axes here. Furthermore, we know that the standard error, meaning the standard deviation of x bar, is sigma over root n. Okay, so you need 1, 2, 3. You need these three things, right? And once we have the sampling distribution, then we can proceed with our hypothesis test. Okay, so we need an estimator for the difference in mean of of the two populations. So what we're trying to what we're trying to estimate is mu1 minus mu2. Well, we won't look at the difference between the two. Well, we want to create an estimator for this. So I'm going to use some new notation here. All right, I'm going to call this theta. Right, theta is just a generic. Let me actually. Theta. Right? Theta is just it's a Greek letter, and is in statistics, theta just means population parameter. It's a generic letter we use to represent all population parameter that we are trying to estimate. Right? So let's create an estimator for this, because this is what we're interested in. Right? And so our estimator that we will create is called theta bar, right? Which is equals x bar 1 minus x bar 2. Nothing fancy, very straightforward. Right? Now, what we need then is, we need the sampling distribution of theta bar. Right? So what we need to know is, well, is theta bar normally distributed? Okay, and then if it is, well, under what condition can we state that it's normally distributed? What is the center of theta bar? Okay, and then most importantly, what is the standard error of theta bar? Okay, all right, we need all these things right? In order to proceed, right? Is the distribution normal, right? What is the center of the distribution, and what is the standard error? Okay, and once we have these three things, then we can proceed with our hypothesis test, and everything else will be exactly the same. Okay, now for this chapter, we're going to focus on the population average, okay, just the mu. And these are the three questions that we're going to ask. Mu1 less than mu2, mu1 equals mu2, mu1 greater than mu2. Okay, and so when we formulate the hypothesis for each of these questions, right, we're going to answer in the following. We're going to write it down in the following way. Okay, so that's how we formulate our hypothesis. We always write all the parameters on one side with the inequality, and then we put 0. We're always asking, right, them relative to each other. Now, it is possible to put a number there, right? If you want to ask specifically, is the average in first population greater than than the second population by a specific amount, or sorry, less than the second population by the specific amount. But we're not going to do that here. That makes the math a little bit more complicated. So keeping a 0 will make our hypothesis test a little bit easier. Now, so this will give us the center. Okay, the fact that we have zeros here tells us that in our null hypothesis, right, that all the theta bar will always be centered at 0. Okay. Second, we need normality. So now for normality, we're going to follow the central limit theorem, right, applies here as well. So we just need one of two things. Right. We don't need both. Right? Okay. We just need one of them. So one, right, is that both populations are normal. Okay, so if both populations are normally distributed, then we can proceed with the test, meaning that we can draw this normal distribution here. Okay, now of course this is a very strong assumption. Okay, and most of the time we are not going to be, well, most of the time we don't know, right? And so that's why it's a strong assumption. Okay, so then if we don't want to make that assumption, then we just need sample size that is large enough. All right, and so central limit theorem applies here, right? We just need the sample size from the first population and the sample size from the second population, right, to be greater than or equal to 30. Okay, once we have these two, right, so again we have the formulating hypothesis, putting 0, right, asking the question, is just simply one greater than or one less than the other, are they equal, or is one bigger than the other, right? Then not just putting 0 here, right? And we have normality, then it gets us, right? It gets us more than halfway there. We can draw a normal distribution. We can say, well, theta bar, which is, by the way, again, is x bar 1 minus x bar 2, right? It is distributed normally with approximately normal distribution, centers at 0. Okay, all right. Now, the hard part, right, is the standard error, right? We still need the standard error to proceed with our test. Now, the calculation of the standard error is going to change depending on different cases. Okay, so that's what we'll talk about now.